Have you ever wondered why blood transfusion is a cornerstone of modern medical practices? It's because blood is fundamental in many medical situations. It's needed in surgeries, to manage traumatic injuries, and to treat chronic illnesses such as sickle cell anemia. In the United States, the annual demand for blood is about 32,000 pints. That's a lot of blood, isn't it? With such a high demand, the dynamics of blood donation and transfusion play a pivotal role in saving lives. But before we delve into the world of blood transfusions, we need to understand the ABO and RH blood systems. Think of blood as a secret language, with your body's immune system acting as the interpreter. The ABO and RH blood systems are the key to understanding this language. In essence, they're the alphabet of your blood, denoting the specific antigens present or absent on the surface of your red blood cells. Let's break it down. The ABO system is based on two antigens, A and B. If your red blood cells have only A antigens, you have type A blood. If they have only B, you're type B. If you have both, you're type AB, and if you have neither, you're type O. But that's not the end of the story. The RH system, named after the rhesus monkey where it was first discovered, introduces another crucial antigen, the D antigen. If your red blood cells carry this D antigen, your blood type is RH positive. If it's missing, you're RH negative. So combining the ABO and RH systems, we have 8 primary blood types: A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Now you might wonder why these antigens matter. Well, they're pivotal in determining blood compatibility. For example, if you're type A and receive type B blood, your immune system won't recognize the B antigens. It will mount an attack, leading to a potentially severe immune response. The same holds true for the RH system. If you're RH negative and receive REH positive blood, your immune system will see the D antigen as an intruder, triggering a similar immune response. So, blood transfusions aren't as simple as pouring one liquid into another. They involve a meticulous matching process, ensuring that the recipient's immune system accepts the donor blood. Now that we know about the ABO and RH systems, let's explore the challenges of rare blood types. Ever heard of the golden blood? It's one of the rarest blood types globally. This isn't your everyday AB or O type. We're talking about RH null, a blood type so rare it's been found in only 43 individuals worldwide. The RH null blood type is characterized by the complete absence of all 61 antigens in the RH system. Imagine that. 61 usual markers that our bodies typically carry, completely missing from these individuals' red blood cells. This absence of antigens gives RH null its rarity and its nickname, the golden blood. Yet with this golden status comes a unique set of challenges. The biggest hurdle, transfusions. Remember, when it comes to blood transfusions, compatibility is key. And in the case of RH null, these individuals can only receive blood from others who share the same blood type. Given the extreme rarity of RH null, this significantly limits the pool of potential donors. But the challenges don't stop there. There are logistical issues to contend with too. Securing a timely transfusion for a RH null individual is no small feat. It's not just about finding a donor. The blood needs to be collected, stored, and transported, all while ensuring it's kept in the right conditions. Add to that bureaucratic hurdles and stringent import rules in certain countries, and you've got a real conundrum on your hands. Despite these complexities, the importance of blood donation remains paramount. Every pint of blood donated has the potential to save lives. And in the case of RH null, each donation is not just a lifeline but a golden opportunity to help someone in need. So while the golden blood may be rare and challenging to handle, it serves as a reminder of the incredible diversity within our own bodies and the power of giving. After all, in the world of blood transfusion, every drop counts. Blood compatibility in transfusions is a precise science, and incompatibility can lead to serious consequences. Blood transfusions are not as simple as pouring one liquid into another vessel. It's all about the intricate dance of antigens and antibodies, a dance that can take a disastrous turn if not performed correctly. Let's dive a little deeper. The compatibility of blood for transfusions is largely determined by the ABO and RH systems. These systems identify the presence or absence of specific antigens on the surface of red blood cells. The ABO system categorizes blood into 4 types, AB, and O, based on the presence of antigens A and B. So what happens if a type A person receives blood from a type B donor? This is where things get tricky. The recipient's immune system recognizes the B antigen as foreign and launches an attack. This immune response can lead to serious, potentially fatal complications. As a rule of thumb, a person with type A blood should ideally receive blood from a type A or O donor, the latter being a universal donor. But wait, there's more. The Rh system introduces another layer to this complex dance of compatibility. It's the D antigen that takes the spotlight here. A person is considered Rh positive if they have the D antigen and Ra negative if they lack it. This becomes especially critical during pregnancy, where an Rh negative mother carrying an Rh positive fetus can result in complications. Now imagine the complications that arise when we consider rare blood types like Rh null, which we discussed earlier. With no Rh antigens present, recipients with this blood type can only receive transfusions from others with the exact same type. Incompatibility in blood transfusions can lead to a series of reactions, from fever and chills to more severe symptoms like kidney failure or even death. This is why meticulous matching is vital in blood transfusions, ensuring each drop of donated blood can do its life-saving work without causing harm. Understanding these systems is just the tip of the iceberg. There's more to blood antigenicity than meets the eye. Indeed, the world of blood types and transfusions is a complex one, and we're just scratching the surface. Beyond the ABO and Rh systems, the broader landscape of blood antigenicity is a fascinating field. The labyrinth of blood types extends far beyond the familiar A, B, AB, and O classifications, revealing an intricate matrix of antigens that define the unique properties of our blood. Indeed, while the ABO and Rh systems are critical, they barely scratch the surface of blood antigenicity. There are numerous other blood group systems that contribute to the complexity of blood typing. These include the Lewis system, the MNS system, and the Kell system, among others. Each of these systems represents a unique set of antigens that can be present on the surface of our red blood cells. Let's take a moment to focus on the Rh system, which plays a more prominent role due to its heightened likelihood of triggering immune responses. While most of us are familiar with the D antigen, the one that gives us our positive or negative Rh status, the Rh system actually comprises a staggering 61 antigens. This intricacy adds another layer of complexity to blood typing and compatibility, making precise matching between donor and recipient even more critical. The task of ensuring compatibility is not a simple one. It's a detailed process that requires a deep understanding of the various blood group systems and the antigens they represent. It's a jigsaw puzzle where every piece must fit perfectly to prevent any adverse reactions. In this broader context, it's clear that blood antigenicity is not just about A, B, and O, or positive and negative. It's about millions of distinct combinations and the precise array of antigens that coat an individual's red blood cells. It's about the intricate dance of compatibility and the delicate balance that sustains life. Blood transfusion has come a long way since its inception, all thanks to medical advancements. From the early explorations of the ABO system to the complexities of the Rh system and beyond, our understanding of blood antigenicity continues to evolve, shaping the future of blood transfusion and, ultimately, saving lives. In the contemporary medical landscape, the heroes are the blood donors. Every drop counts, every pint matters, and every donor makes a difference. The selfless act of blood donation transcends beyond an act of charity. It is a lifeline, a beacon of hope for those in dire need. It's a marvel of modern medicine that we can share a part of ourselves to help another, and this act of giving is embodied in the practice of blood donation. Blood types may differ, but the need for blood is universal. From the most common type O to the rarest golden blood, Rh null, each donation plays a pivotal role in the intricate tapestry of healthcare. One person's donation can potentially save up to 3 lives, illustrating the significant impact of this simple act. The altruism of blood donors ensures a steady supply of this life-sustaining fluid, bridging the gap between life and death, health and sickness. It's not just about the blood, it's about the spirit of giving, the courage to roll up one's sleeve and make a difference. Blood donation stands as a testament to our shared humanity, a bond that unites us all. It's an act that requires no special skills, just a willingness to help others. A pint of blood may seem insignificant to the donor, but for someone fighting for their life, it's priceless. So next time you think about donating blood, Remember, your contribution could save a life.